Hey guys, what's up? This is YouTube channel Proton classes and this is solid state part 2. In this video we study about different types of crystalline solids. There are different types of crystalline solids. First we have molecular solids. These different types of crystalline solids are basically divided on the basis of nature of intermolecular forces. What these solids depend on the intermolecular forces, the type of intermolecular forces. These are molecular solids. Next one is ionic solids, metallic solids, and covalent solids. First, we are studying molecular solids. In molecular solids, these molecular solids are further classified into non-polar molecular solids, polar molecular solids, and last one is hydrogen bonding solids. The first here is non-polar molecular solids. These molecular solids, as the name signifies, the compounds are non-polar. They have no dipole moment. They comprise of either atoms or molecules. If they are atoms, they are unreactive elements like argon and helium. And if they are molecules, they will be non-polar covalent compounds like H2, Cl2, and I2, where the polarity is zero. Polarity is zero. Now, next point is weak dispersion forces. We have already studied in 11th class what are London forces and dispersion forces. These are very weak forces. These weak forces comprises in molecular solids. Next one is these solids are soft. Why soft? Because they are made up of weak dispersion forces. They are Next point is they are non-conductors of electricity because there is no presence of ions or electrons. That's why they are non-conductors of electricity. They have again low melting points because they have weak dispersion forces. Next one is they have the attractive forces are very weak, therefore they are found in mostly in liquids or gaseous states at room temperature. The next type of solids, molecular solids, are polar molecular solids. Polar, as the name signifies, is polar molecule, means they have a dipole moment. Second point is dipole-dipole interaction. There will be dipole-dipole interactions. Next one is non-conductors of electricity because here also the absence of ions or electrons. Next is melting points are higher than those of non-molar molecular solids because here attractions are more. Next examples are solid sulfur dioxide and solid ammonia are examples of polar molecular solids. The last is the hydrogen molecular solids. The hydrogen bonded molecular solids. The name signifies there is always a hydrogen bond. There is always a hydrogen bond. Hydrogen bond is always formed between H, F, H, O, H, N. These comprises hydrogen bond. These are also non-conductors of electricity. All molecular solids are non-conductors of electricity. The common point among these polar, non-polar, and hydrogen bonded solids are all are non-conductors of electricity. Last, hydrogen bonded molecular solids volatile. These molecules are volatile, soft solids under room temperature. The next one is ionic solids. The main constituent part in ionic solids are just ions. Ions constitute ionic solids. These form three-dimensional arrangements of cations and anions. Cations are positively charged and ions are negatively charged by strong Coulombic forces. By strong, you would study in first chapter of physics what are Coulomb forces. These are just electrostatic forces. The attraction between a positive and negative charge. These forces are Coulombic forces or electrostatic forces. But these solids are hard and brittle, like NaCl. NaCl is made up of Na cation and Cl as anion. They have high melting point because attractive forces are very strong and boiling point is also high. Next one, because these are constituent of ions and therefore these are electrically insulate, but these are electrical insulators in solid state, but not in liquid state. In liquid state, they constitute current. In molten state or when dissolved in water, the ions become free and to move and so therefore conduct electricity. But in case of solids, these ions are static and they can't move, therefore they doesn't conduct electricity. The best example is NaCl, common salt, that we eat every day. Next one is metallic solids. Metallic solids are just a collection of positively charged ions. Positively charged ions are also called kernels, are held together by free electrons. These free electrons. Next one, electron. In metallic solids like copper, etc., copper, iron, electrons are mobile. They are free electrons. They were free electrons, so they conduct electricity. Next one is free immobile electrons are responsible for high electrical and thermal conductivity. Thermal conductivity means conductors of heat. Next one is when electric field is applied, these electrons flow in the particular direction and conducts electricity. Therefore, here conductor is electron. Or, for electricity is electron. But in ionic solids, the conductors were ions, which constitutes current. Like we have already studied that metals are malleable and ductile. Therefore, metallic solids are also malleable and ductile. The last solids are covalent and network solids, or they are also called network solids because they form networks. First point is strong, directional in nature. They are aligned in a particular direction and held very strongly at their positions. They are also hard and brittle. High melting point because strong forces are there, may even decompose before melting. Next one, these are insulators. These does not conduct electricity. For example, diamond and silicon carbide are good examples of covalent solids. This is just a chart of different types of solids that we studied above. Type of solid, molecular, non-polar, polar, hydrogen. These are just a glimpse, a collection of above points in differentiation path, in differences. Next one we are going to do some in-text questions. First one, we have to classify these on the basis of intermolecular forces. I want to give a point here that you can take these notes from our websites, Proton classes.in. You can take these notes free from our website. These notes are really enriched and you can get each and every question from these notes only. No need to study from different books. Now come to the question. Different categories on the basis of nature of intermolecular forces. These are we have classified as ionic solids, covalent solids, molecular solids, and metallic solids. The reason why we have classified these part are ionic solids, covalent solids, covalent bonds, and metals. Because rubidium and tin are metals, therefore these are classified under metallic solids. Ionic solids, potassium sulfate and zinc sulfide are consisting of ions, therefore classified under ionic solids. Covalent solids because they are covalent in nature. Molecular solids because they form molecules. Urea, ammonia, water, argon, they form of molecules. And they are not giant shapes. But these are silicon carbide and graphite are giant molecules. Therefore classified under covalent giant molecules. So next question is, solid A is very hard electrical insulator. The point is electrical insulator, solid as well as in molten. Means it doesn't conduct electricity in solid state as well as molten state and melts at extremely high temperature. What type of solid is this? Because this is an insulator, therefore solid A is an insulator in solid, shows the absence of ions. Why the absence of ions? Because it doesn't have conduct electricity in solid as well as in molten. Because if it was ionic solid, then it will have to conduct electricity in molten state, but it does not conduct electricity in molten state, therefore it is not an ionic solid. Next, Hint is melts at extremely high temperature. Melts at extremely high temperature, so it is a giant molecule. Giant molecule. These are the properties of covalent solid, therefore it is a covalent solid, and in particular we can say giant covalent solid. Hope you got my point. Next question is, ionic solids conduct electricity in molten state but not in solid state. Explain. This point we have already given. Why conduct? Because in molten state ions can move, but in solid state ions cannot move. So, but to conduct electricity, to form electricity, ions have to move. Therefore, in solid state they doesn't move. Therefore, they doesn't conduct electricity. The last one is whatever solids are electrical conductors, malleable and ductile. These are metallic solids because they are uh, conduct electricity. They are malleable and they are ductile, metallic solids. Thanks for watching. More about this chapter in next video.